Next question. In which of the following pairs the two species are not isostructural? What is meant by that? Isostructural means those ions or species having the same structure. So here we have to select the species which are not isostructural, means they should not have same structure. Let us check the options. First one is carbonate ion CO3 2 minus, and the next one is NO3 minus ion. To know the structure, we need to see the hybridization. That is, what is the formula for hybridization? Half into number of valence electrons plus number of monovalent atoms minus number of cationic charges plus number of anionic charges. This is the formula for steric number. In case of carbon, there are 4 valence electrons and anionic charges are 2. So the answer would be 3. It is sp2 hybridization. Coming to nitrate ion, half into number of valence electrons 5 plus 1 anionic charge, and it is again 3, and it is sp2 hybridization. And so this is not our correct answer. Let us see next option. It is PCl4 and SiCl4. PCl4 plus SiCl4. For phosphorus, number of valence electrons are 5 and monovalent atoms are there. It is 4 minus 1. That would be 4. It is sp3 hybridization. And coming to SiCl4, it is half into number of valence electrons 4 plus number of monovalent atoms 4. So it is also 4 sp3 hybridization. So this is also not the correct answer. Let us check another option, PF5 and BRF5. So what is for phosphorus? Again, half into number of valence electrons 5 plus number of monovalent atoms 5. It is 5. And hybridization is sp3 dehybridization. Coming to BRF5, number of valence electrons are 7 and number of monovalent atoms are 5. So this would be 6 and it is sp3 D2 hybridization, and definitely the structure is not same. So these are not isostructural because we are getting sp3d hybridization and sp3d2 hybridization. We know that for sp3d hybridization, it is trigonal bipyramidal, and for sp3d2 hybridization, it is octahedral. So this is our correct answer. Next question. Among the following, the maximum covalent character is shown by the compound. So we need to check which of the following is having the maximum covalent character. The options that we have are SnCl2, AlCl3, MgCl2 and FeCl2. We know that Sn is in +2 state here, aluminium is in +3 state in this compound, and magnesium is in +2 state, and iron is in Fe is +2 state. So we know that higher the charge, more is the covalent character. So for aluminium, we have +3, so it will be having more covalent character, and also the size of aluminium ion is lesser when compared to magnesium here. And we know SnCl2 and FeCl2 are ionic in nature. They have ionic character. So our correct answer is AlCl3. Next question, the hybridization of orbitals of nitrogen atom in nitrate ion, NO2 plus ion and ammonium ion are respectively. To know the hybridizations, we need to calculate the steric number. How do we calculate the steric number? Write the formula. So half into number of valence electrons of nitrogen is 5 and there are no any monovalent atoms and one anionic charge is there. So add 1 and it would be 6 by 2, that is 3, and if it is 3, it is sp2 hybridization. And calculate the steric number for NO2 plus ion. So half into number of valence electrons, there are no any monovalent atoms and one cationic charge is there. So subtract 1 from this. 5 minus 1 is 4 and 4 by 2 is 2 and it is sp hybridization if the steric number is 2. And coming to ammonium ion, it is NH4 plus. So half into number of valence electrons 5 plus hydrogen has monovalent, right? So 4 and plus charge is there. That means it's a cationic charge. So minus 1 here and it would be 8 by 2, it is 4 and it is sp3 hybridization. So our answer is sp2, sp, sp3 respectively. So sp2, sp, sp3 and it is option B. So the next question is the structure of IF7. So when you see the molecule formula itself, IF7 means how many terminal atoms are there? 7 terminal atoms are there. That means 7 bond pairs are there. 7 bond pairs are there means you just see the structures. In trigonal bipyramidal, only 5 bond pairs will be there. And in octahedral, 6 bond pairs will be there. And in pentagonal bipyramidal, 7 bond pairs will be there. And square pyramidal, how many bond pairs do we have? It is only 5 again here, bond pairs. So our answer is option C, pentagonal bipyramidal for IF7 molecule. Using MO theory, predict which of the following species has the shortest bond length. To know the one which is having the shortest bond length, we need to check the bond order, because bond order is inversely proportional to bond length. That means higher the bond order, shorter will be the bond length. So let us calculate the bond order. For first option, O2 plus, the total number of electrons will be 15 electrons, because 16 minus 1, a plus charge is there. 15 electrons, the MO configuration will be like this for 15 electrons, and the bond order is half into number of bonding electrons will be here, anti-bonding electrons are 5. So 10 minus 5, 5 by 2, and it will be 2.5. Bond order is 2.5 for O2 plus. And the second option is O2 minus. O2 minus means 16 plus 1 electron. That means it is 17 electrons. And for 17 electrons, the MO2 configuration changes a little, and it will be 2 over here and 1 over here. So the number of bonding electrons and the number of anti-bonding electrons are again changing. For a O2 minus, half into number of bonding electrons 10, and number of anti-bonding electrons are 7. Let us check. Here 2 makes it 4, 5, 6, and so it is 7, and this will be 1.5. So the bond order for O2 minus is 1.5. Let us see for O2 2 minus. O2 2 minus means totally it will be having 18 electrons, 16 plus 2, and the MOT configuration changes here, and that is 2 over here. So again the number of anti-bonding electrons are increasing, right? So let us make this 8 for O2 2 minus, and this would be 10 minus 8, and so it is, the bond order will be 1 for O2 2 minus. And O2 2 plus, number of electrons will be 16 minus 2, it is 14 electrons, and for 14 electrons the MO configuration is this one. So the bond order also changes. Number of bonding electrons will be 10 only, and number of anti-bonding electrons are just 4. So half into 10 minus 4, that will be, half into 10 minus 4 is 6 by 2, and it is 3. So O2 2 plus is having highest bond order, and so this will be having the shortest bond length. Which of the following pair of species have the same bond order? We need to check which of the two is having the same bond order. Same bond order means it should have same number of electrons, because isoelectronic species will be having the same bond order. And let us calculate the number of electrons in Cn minus and NO plus. In carbon 6 electrons, and in nitrogen 7 electrons, and a minus is there. So plus 1 electron, that would be 14 electrons, and in NO plus 7 plus 8 minus 1, and it is 14 electrons. So our answer is Cn minus and NO plus. Let us check anyway the other options as well. Cn minus is having how many electrons? It is having 14 electrons, and Cn plus means obviously 6 plus 7 minus 1, and it is 12 electrons in the second option. So second option is not correct. And O2 2 minus, in the third option we have Cn minus and O2 2 minus. O2 2 minus means oxygen plus 1 electron, so it makes 17 electrons, and Cn minus is 14. So this is also not correct. And NO plus we are having 14 electrons, and Cn plus how many are we having? 12 electrons, and so this is also not correct. So our answer is option A. Next question, the bond dissociation energy of boron fluorine in BF3 is 646 kilojoules per mole, whereas the CF bond dissociation in CF4 is 515 kilojoules per mole. The correct reason for the higher bond dissociation energy in boron trifluoride as compared to that of CF bond in CF4 is. So we need to tell why it is 646 in BF3 whereas it is only 515 in CF4. And we know that boron trifluoride, it will be like this. 3 fluorines, central atom is boron, and one vacant p orbital will be there on boron. And coming to fluorine, we have filled p orbitals in fluorine. We have filled p orbitals. So there exists a p pi interaction between the vacant orbitals of boron and filled orbitals of fluorine, and so because of this interaction the bond enthalpy increases in BF3, whereas if you take CF4 you don't see such interaction because carbon doesn't have any vacant p orbitals, because carbon's valency is tetravalency and 4 fluorine atoms are there, so 4 bond pairs are there, so there are no vacant p orbitals, and so there is no p pi interaction in CF4. So our correct answer is significant p pi interaction between boron and fluorine in BF3, whereas there is no possibility of such interaction between carbon and fluorine in CF4. Next question. The charge to size ratio of a cation determines its polarizing power. Which of the following sequences represents the increasing order of the polarizing power of the cationic species K plus, Ca2 plus, Mg2 plus and Be2 plus? So we know that if charge is more, then the polarizing power is more. So Be2 plus, Mg2 plus and Ca2 plus, they are having more charges. So first let us write an order for this, because K plus is just only plus 1. Right? And so it will be like this. Among these three, we know that as we go down the group, what will happen to the size of the ion? The size of the ion increases, and smaller the size, more will be the polarizing power. And so our order will be like this. Smaller the size, the polarizing power increases, and higher the charge, the polarizing power increases. So this is the order, and our answer is option B. Which of the following species exhibits the diamagnetic behavior? For a species to exhibit diamagnetic behavior, all electrons should be paired. If at least one electron is unpaired, then also it is paramagnetic behavior. So if electrons are to be paired, then it should contain even number of electrons, and we can get unpaired electrons with even or odd number of electrons, but for paired electrons definitely it is even number. Let us calculate the number of electrons in these following species, and it is 18 in O2 2 minus and 15 in NO. O2 plus it is 15 and O2 it is 16. So let us write the configuration, because NO and O2 plus, it is ruled out because they are containing odd number of electrons, and there is a chance that in O2 2 minus and O2 we are having even number of electrons. If you write the MO configuration for the option A, it will be like this, and you can see that all electrons are paired in O2 2 minus. So our correct answer is O2 2 minus. Let us check the O2 as well, whether the electrons are paired or unpaired, and here it is 16 electrons, so we have to write the configuration like this. For 16 electrons, it is like this. That means 2 unpaired electrons are there, and so this is not diamagnetic and this is paramagnetic, so not correct answer. So our answer is option A. In which of the following ionization processes the bond order has increased and the magnetic behavior has changed? That means we need to select the option in which the bond order is increasing and the magnetic behavior also should change. That means if it is paramagnetic, it should become diamagnetic. If it is diamagnetic, then it should become paramagnetic. So let us check our options. Option A is N2 and it should become N2 plus. That means N2 it is 14 electrons and N2 plus it is 13 electrons. For 14 electrons, this is the MOT configuration, and the bond order for N2 is half into number of bonding electrons minus number of anti-bonding electrons, and so it is 10 minus 4, and that is 3. So bond order for N2 is 3. And what about N2 plus? We need to remove one electron from here. This will become 1, and if that is 1, and it will be half into 9 minus 4, that is 5, 5 by 2, and it is 2.5. So the bond order is decreasing and it is not increasing. So this is not a correct answer. Let us check the second option. Second option is carbon molecule C2. C2 means how many electrons are there in C2? It is 12 electrons, and so the configuration will be this one for C2 molecule. And from C2, let us check the bond order for C2. Number of bonding electrons, it is 8. Anti-bonding 4. So the bond order is 2 for C2. And what about C2 plus? We need to remove one electron, make this one electron. And now it is 7 minus 4. If it is 7 minus 4, that is by 2, isn't it? 3 by 2, and it is for C2 plus 1.5. So bond order is decreasing. 1.5 means it is not increasing. So these two are not our answers. Then let us check the third option. It is NO to NO plus. In NO, how many number of electrons are there? It is 15 electrons, because 7 in nitrogen and 8 electrons in oxygen. And so it is 15 electrons. For 15 electrons, the MOT configuration, we have to change a little bit here. So here it is 2, and after this sigma 2pz 2 and sigma star 2px, sigma star 2py. Here it is 1 electron. And let us check the bond order for this. So total it is 15 electrons, and number of bonding electrons is 10, and number of anti-bonding electrons is 5. And so it is 5 by 2. Isn't 5 by 2 is 2.5. For NO, it is 2.5. What about NO plus? In NO plus, remove this electron to get NO plus MOT configuration. When we remove this electron, we are removing the anti-bonding electron. That means the bond order also changes here. What is the bond order? It is 1 by 2 into 10 minus 4, and that would be 6 by 2, and it is 3. So the bond order is increasing here. Bond order is increasing, and let us check. Previously, there was 1 electron in anti-bonding. So NO molecule is paramagnetic in nature, and NO plus, if you observe, all are paired electrons, and so it is diamagnetic in nature. So this option satisfies both the conditions in which the bond order is increasing and magnetic behavior is also changing. So that is our correct answer. Which of the following hydrogen bonds is the strongest? So to answer this question, let us see the electronegativity difference between hydrogen and other atoms. So you have here nitrogen, fluorine, and oxygen. Among these three, fluorine has more electronegativity. So this must be stronger, and here also it is fluorine only. So these two must be stronger. Among these two, let us compare this fluorine and this oxygens. Oxygen is less electronegative than fluorine, and so because of its higher electronegativity, it pulls the electrons more towards itself than oxygen. And so this hydrogen will get more partial positive charge when compared to this hydrogen. That's why, because of the difference in the electronegativity also here increases, because this hydrogen is getting more partial positive charge when compared to this hydrogen, and this will become the more electronegative. So our answer is option B. Next question, which of the following molecules or ions does not contain unpaired electrons? So when you write the MO configuration, you should not get any unpaired electrons. So let us check the first option, N2 2 minus. N2 2 minus means we have to write it for 16 electrons. For 16 electrons, we'll get the configuration like this. And you can see here 1 and 1. That means unpaired electrons are present here. So this is not our correct answer. Let us check the option B, and it is B2. That means boron molecule. It has 10 electrons. So how to write the electronic configuration for 10 electrons? Make these two as 1 and 1. That would be configuration for 10 electrons, and definitely you can see that here also unpaired electrons are present. So these two are not our correct options. And let us check the third option, O2 2 minus. O2 2 minus means 16 plus 2. For 18 electrons, we need to write the MOT configuration, and this is the MOT configuration for O2 2 minus, and you can see all electrons are paired here and there are no any unpaired electrons. So this is our correct answer, option number C, O2 2 minus. Next question, in which of the following molecules or ions are all the bonds not equal? That means we need to check the shape in which all the bonds are not equal. First option is XeF4. XeF4 is square planar. So square planar means it will be like this and all are equal. So that is not our correct answer. Coming to BF4 minus, it is tetrahedral. So even in tetrahedral, all the bonds are equal. So this is also not correct answer. And SiF4, that is also tetrahedral, so not correct answer. Coming to SF4, it is seesaw. Seesaw means it has formed from trigonal bipyramidal shape. That means one will be a lone pair. So it has got a seesaw shape. If this is lone pair, this is seesaw shape. And we know in trigonal bipyramidal, the axial bonds are longer than the equatorial bonds. That means these bond lengths are little bit more when compared to these two equatorial bonds. So our correct answer is seesaw, in which all bonds are not equal, and it is SF4 molecule, and option C. The decreasing values of bond angles from ammonia to antimony trihydrate down group 15 of the periodic table is due to. What happens to electronegativity down the group? Down the group, the electronegativity decreases. So ammonia is in ammonia, nitrogen is having more electronegativity when compared to the other elements in those trihydrates. That means they attract the electron pair more towards itself because of their electronegativity. So here nitrogen is attracting the electron pair more towards itself, and this is not attracting that much. So what happens, the bond pairs, they stay close to nitrogen when compared to the other molecules. When they are very close to the nitrogen, the repulsions between them will be more, and when they are far away from the central metal atom, the repulsions between them will be less. When the repulsions are less, obviously the bond, they become more closer, and so the bond angles decreases. All this is happening because of the decreasing electronegativity down the group, and so the answer is option D. Next question, lattice energy of an ionic compound depends on. The options are charge on the ion only, size of the ion only, packing of ions only, and charge on the ion and size of the ion. We know that lattice energy of ionic compounds depend on charge on the ion and size of the ion, because the distance between them is governed by the size. So on both these two factors, the lattice energy of the ionic compounds will depend on. So the correct answer is charge on the ion and size of the ion, option D. Next question, the correct order of bond angles in H2S, NH3, BF3 and SiH4 is. In H2S, hybridization is sp3 hybridization with 92-degree bond angle because of presence of lone pairs. In ammonia, sp3 hybridization with one lone pair, so it is 107-degree. In boron trifluoride, sp2 hybridization with 120-degree bond angle. In SiH4, it is sp3 hybridization and 109.5 degree. So our correct order is option C. Next question, the bond order in NO is 2.5 while that in NO plus is 3. Which of the following statements is true for these two species? So we know that bond order is inversely proportional to bond length. And here the bond order is less, and here the bond order is more. That means which is having more bond length? The one with lesser bond order is having more bond length. So NO is having greater bond length when compared to NO plus, and so our answer is option D. Next question, the states of hybridization of boron and oxygen atoms in boric acid H3BO3 are. So to answer this question, first we have to write the structure of boric acid. So it will be like this, boron, and it is attached to 3OH. This is the structure of boric acid. So here boron has 3 bonds. 3 bonds means it must be 3 sigma bonds. So it is sp2 hybridization for boron. And coming to oxygen, oxygen is having 2 sigma bonds and 2 lone pairs are obviously present. So 2 sigma bonds and 2 lone pairs makes it sp3 hybridized. So our answer is option D. Which one of the following has the regular tetrahedral structure? In the given options, XeF4 has sp3d2 hybridization and shape is square planar. In NiCN4 2 minus dsp2 hybridization, again square planar. BF4 minus sp3 hybridization and it is tetrahedral geometry. SF4, it is sp3d hybridization with seesaw shape. So our answer is BF4 minus. The maximum number of 90-degree angles between bond pair of electrons is observed in. In DSP3, the hybridization is trigonal bipyramidal with two 90 degrees and three 120-degree angles. In DSP2, it is square planar with four 90-degree angles. And in sp3d2, it is octahedral geometry with 12 90 degrees. And sp3d, it is 690 degrees. So our option answer is sp3d2.